Paul, thank you. We appreciate the opportunity to be included here in your symposium today. It's titled a technical symposium, so this probably appropriate for PFF for us to go first. This may be probably the least technical of the presentations you have scheduled. I know you have a great lineup today and tomorrow. But in looking at it, we kind of came up together, you and I, on a title as Fundamentals of Superior Lagoon Cover Design and Installation. And I think that's a great title, but as I thought about it more last night, it might be just in a more simple version. Our title maybe should have been something along the lines of stuff that we know that works in AD covers in lagoon design and installation. PFF, we've been in the been around for about over 40 years. We put our first covers in probably 30 years ago now. And much of our original work was done in the industrial plant world, mainly in response to nuisance litigation, odor control, those type of things. Where the original kind of floating cover design was for that. And then, in the last 10 years, we've seen a major shift in the purpose of these covers for maximum containment is kind of how we describe it. And with that, they want gas storage capabilities and as well as an ease of extraction of gas from underneath the covers. And so our design and what we do today is focused largely on ensuring those three kind of properties are included in our lagoons. It's all that kind of stems from, I think our first ones, we were installing flares as well, because that's what the gas was used for. And now we're often no flares included, and the gas, the owners much rather have it stored under the cover so it can be used and upgraded. So it's been a big shift in the business and a big shift in our design in the last 30 years. Again, PFF, my name is Bland Warren. My partner and I acquired the company about 8 years ago. I've served as CEO since that time. We have two kind of primary business units in the environmental containment world. One's in the landfills side, and then our other side of our business is in the wastewater business. That's where the lagoons and lagoon covers come in. In addition, we have a fabrication department here in our headquarters in Huntsville, Alabama, that we build piping systems, wet wells, vaults, manholes, things of that nature that kind of support both our lagoon cover business and our landfill business. We look at an anaerobic digester cover mainly, similar to what probably the owners, developers in your projects, in the gas projects, look at like any other equipment purchase. These are assets. We look at it and view it as a value proposition. The value proposition doesn't only include low cost, but it also includes performance, long-time performance, operating costs, life expectancy, things of those nature. So we look at it just like if you're buying a compressor, a piece of upgrade equipment, things of that nature. That's how we view our covers in the process. Is how we fit in an overall RNG project. PFF, when we started in the cover business, we really, the majority of our work was in the large industrial process plants, where that in the protein, paper and pulp plants, things of that nature, were large wastewater lagoons that we covered. Again, when you work in the industrial world, safety, construction design, this value proposition is a big part of their decision-making process. And we've tried to really take that over and transition that into, you know, the agricultural world in the areas where we're seeing a lot of growth of our business in the last, you know, 5 to 10 years. I do want to talk about a little bit today from a design standpoint. We'll touch on, you know, really an anchor trench in the ballast system, sludge removal, mixing systems that are all go into our AD cover design. But a couple other things I just want to take a minute to talk about that I think are really important before we kind of dive into some of those details. PFF, we provide, you know, operational support for our digesters. This includes operational support, routine maintenance, annual inspections. We do this regularly on our covers that we've installed, and we also do them for clients on covers that have been installed by others. We feel this routine maintenance and annual inspections is, you know, and the preventative maintenance goes along with that, is vital for the long-term reliability and efficiency of our digester systems. The first kind of area that I want to touch on today, in terms of just a technical and some areas that we've made a lot of improvements in the last 10 years as we move towards this area of, you know, kind of maximum containment of the gas under our lagoon covers, is in the anchor trench. You know, the anchor trench obviously provides the structural integrity to hold the cover in place, but it's also an area that, if not designed correctly, it can provide areas for leaking, and that you could, you know, kind of lose gas that way. So there are a couple things that that we've done in the last few years, we've been exposed to, that I think make a huge difference. First thing is this: if you have a lined lagoon, and it's, you know, being built new for a project, we certainly recommend that it be lined. And if it's lined, then the cover and the liner would be welded together before they're secured in the anchor trench. That's going to give you your best gas containment. But unfortunately, many of the projects we work on, especially in the agricultural world, we're covering existing lagoons. You know, many of the farm operations, things of that nature, were using open lagoons for their AD long before the gas projects came along, and the economics dictate that we're just going to cover those. And so when we do that, you know, a couple of things that really to keep in mind is, you know, in these lagoons like this, most of them are clay lined. They don't have a synthetic liner. So if that's the case, we want to make sure that we fortify the anchor trench, you know, to give the to yield the containment properties that they're looking for. A couple of things we've learned there. You know, first thing we do is let's look at the look at the soil composition. And most of these lagoons are clay lined. Does the clay liner extend up into the anchor trench and down through the anchor trench? If not, we've gone back and had the civil contractor make sure that they do that, so that we have a good seal, not only from the water level, but all the way up the freeboard into the anchor trench. Makes a big difference as we're looking to contain the gas. Another area that we look at, and when we talk about that, is what is the soil composition in terms of, is it a sandy soil, kind of a rocky, large granular soil, things that make it easy for the gas to migrate through. In those cases, we usually add bentonite or a GCL to the bottom of the anchor trench, so that it can hydrate and provide that seal. It would go underneath the cover in the anchor trench before it's backfilled and compacted. And in some instances, we've even installed a simple irrigation system in there, so that we can ensure that bentonite is hydrated and can do its job to help create a seal. Again, back for the maximum containment that's required in this day and age from these lagoons. And before I switch off of this one thing I want to show on this picture is that you can notice just on the interior of the anchor trench there is our biogas collection pipe, and that extends around the entire perimeter of the lagoon. And I'll touch on that again here in a second. Again, you can see the biogas collection pipe there. It shows it a little bit better in this photo. And we'll come back to that. You can see the GCL that we've put in there. Again, that's going in before the liner is deployed there on the right. And the idea there is that once that's hydrated and expands, it'll help create that seal. And the reason we look at this and doing some of these ahead of time is it's very costly and very difficult to go back and fix leaks that occur in the anchor trench after construction is completed. The second kind of component that we look at as we want to talk about kind of the shift in the requirements of these our AD lagoons is specifically for RNG projects, is that PFF through the years we've developed a kind of a proprietary ballast system that we think is ideally designed especially for RNG projects. And a couple of the unique features that we have, a little bit different than maybe what you've seen. If you look at the photograph on the left, you can see that's a lagoon that has very little gas under the cover, but it illustrates the ballast system well. You can see our the ballast system is fused into one kind of monolithic structure, and it's fused in the center with fabricated crosses that PFF has fabricated. And these crosses provide a lot of strength and integrity for the ballast system that really works well for today's requirements. If you look on the right, same ballast system in a different lagoon. This is an agricultural setting, obviously, and this is a lagoon system that we think is working, very well in terms of the gas is evenly distributed under the cover. The rainwater is migrating to the middle, and then there's no obstruction. The gas can flow easily from under the cover to the exterior ballast system. These covers, are in the RNG world now, or in the AD cover world now. There's always a big requirement for storage. We're trying to optimize the gas upgrade systems. So, there'll be times of gas production that exceeds the capacity of the equipment. You want to be able to have some storage built in as well. So you can see in the cover on the right, certainly there's some excess gas being stored there until it can be upgraded. And with that kind of storage requirement, it puts extra stresses on the cover, especially as it's exposed to the wind and other elements. And so our ballast system, really handles that very well. It stays in place. That's a big issue that we see today. Probably the biggest hidden operating cost that we see in lagoon cover systems today is that the covers, the ballast system will move out of place when the forces of the inflation and wind are put on the cover system or on the ballast system. And these ballast pipes and these that are on the covers, they're filled with a grout, flowable grout, or concrete. The pipes are very heavy, but they will move. They will, if they're not secured properly on the cover. And when they do move, it's very expensive to get them put back into place. You're talking about large crews, labor, heavy equipment, and maybe even a crane or two required to reposition these back in place. So it's imperative that they don't move over the life of the cover. And as we have this dynamic forces working on these covers, we think it's imperative to use a cover design like we have here illustrated, where the ballast system is fused together. It cannot move on the cover. It's one system where the spine, central spine, and the laterals are all working in concert together. A couple other things on this cover here that I also want to talk about that the ballast system does. It promotes the flow of the rainwater to the center ballast, and also and then to the ends of the lagoon, as you can see illustrated here. I'll show you. I'll go over that again here in a future slide. And then the other major feature that you can look at here is that the ballast system is in the center, and the laterals do not extend all the way to the edges. There is no perimeter ballast. So this promotes the easy flow, efficient flow of the gas from under the cover to the perimeter gas extraction pipe. And in many of the early designs that we see today on ballast systems, on covers, many employ an external or perimeter ballast system, kind of around where the toe of the slope and the water line would be. And those are great on lay flat covers and when there's not going to be inflation of the cover. But today, what we see is with the gas storage requirements, the inflation that goes on with those often will trap gas under covers and make it difficult for extraction.
Hey, Bland, we got a couple of good questions came in.
Yeah, okay. Please.
So maybe we can just hit them quick. Can you comment on digester heating, if that's anything you feel is viable? I made mention that it's just really hard to cost competitively justify all of that energy into such a huge volume of water, but any other insight you have there is one. And number two, could you speak to methane leakage from the cover? Can that happen? And maybe some of the monitoring capabilities you've been leading with lately?
Yeah, no, all good questions. I may ask you to give me those one at a time here in a second.
Okay, so heating.
Yeah, heating is absolutely. We do insulate covers, and we can and so when we do that, the cover would be designed just as it's shown here in this photo, and then we would put attach and encapsulate an insulation of foam, usually a closed cell foam insulation, on the top of the cover to increase its insulating properties. We do that a lot in the upper Midwest in the colder climates. And then in terms of actually providing heat or into the cover, that's really not an area that we get into. We have especially in the industrial process plants where they have a lot of hot water and other things, that I know that they are adding that to promote digestion. And yes, but really from our standpoint, we are tasked with usually just with insulating the cover. And yes, you can get some pretty good R factors there that increase that insulation.
And number two was methane leakage.
Yeah, methane leakage. So I think I showed back on a slide earlier, but yeah, methane leak testing is certainly become as we kind of go to this maximum containment world. These projects have moved from kind of the wastewater world into the CFO's desk, so to speak, and so containing that gas becomes and measuring that is very important. We've employed some of the testing firms that come and provide kind of the drone testing and other testing for methane leak detection. And then also just some of the handheld testing that goes on. What we found is very that they're usually they find a little methane gas, but when you kind of get to the parts per million, it's very rare that we have any significant gas leaking, especially with the designs that we're talking about.
Okay, thank
But
you.
I would be curious what anybody else has had in terms of, there's one thing to detect a leak. The other is the quantity of the gas. And often what we find on a cover, and if you'll, I'll try to go back to a slide here. If you look at this slide here, that was a cover that was tested, and you can see some areas maybe that show up in red in that bottom left corner. But there's very small, parts per million. And of course, the gas is heavier than the air, so it's going to settle in areas. And what we found on some of this testing is you have to be careful is that where you may find some accumulations of gas is not actually where a leak is. And so it's kind of a little bit of a trial and error process when you're trying to track down a leak.
Some other good questions coming in. So you have some really longevity in your installations, some that go back decades. How does a 15-year-old cover look versus a new cover? Can you speak to like wear and tear and brittleness, and is there maintenance that you do on covers as they age?
Yeah. So as again, kind of a theme that we're seeing now is a lot of our large corporate customers have been through maybe a full life cycle, 20 plus years on covers. Some that we installed that are in the field or have been in operation, probably 25 plus years. On a lot of them, we have gone back to do regular inspection and maintenance. Paul, it's no different than kind of going to get your teeth cleaned at the dentist. You go get it checked for a cavity, and it's not that bad. But if you don't do that, these things, the kind of the root canal that goes on with a cover failure, it can be pretty significant. And certainly
is there a high-low temperature for ambient that you're comfortable putting in digesters, low temp and high temp?
Just as it relates mainly to the welding of the HDPE material, as long as you're within the welding parameters. So that's, we're fine. We've done them in very cold climates, very, very warm climates. So that's really hadn't been an issue. But the routine maintenance certainly extends the life of the covers. And now we're starting to, as folks are starting to get empirical data on the operating cost, and the value of the preventative maintenance is really starting to shine through. Because if you have a ballast pipe system that gets out of place and other things, we're talking tens of thousands of dollars, if not 100,000, to get it fixed.
Okay, we'll let you get back to your
no problem.
Slides.
Yeah. So again, this is
questions coming though.
Yeah, no, please keep them coming. Again, this is what we consider a really healthy agricultural lagoon. I think I went over most of this already, but it promotes the gas flow to the exterior, centralized rain collection, and the even flow. We kind of like keys on a keyboard there. When you get uneven accumulation of gas, you get the bubbles. When you have the overinflation in the wind there, that creates significant stresses. So that's one of the things we're looking for, obviously, in kind of annual inspection, routine maintenance. This is just a little closer slide to kind of show our ballast system. It illustrates the cross there in the middle. So you can kind of see the 8-inch lateral, the 8-inch spine, and then the 6-inch laterals all fused together there. And this really gives an illustration with the patches and straps around all four sides of the cross there. It really holds that in place better than any other system that we've found. And plus it keeps it from extending to the perimeter of the lagoon, which, really makes a difference in gas extraction, also just maintenance around the lagoon. Again, when we put these in, we have many like this that have been in place 20 years. They haven't moved and haven't created any excess. cost or operating cost for the owner. And I will add, on our ballast system here, Paul, is that it is, we do do this from time to time as well. So there are covers that we did not install originally that have a different design. If they're struggling with the ballast and keeping the ballast in place, we've gone in and retro fit these on existing covers. So that's something we certainly are comfortable with and have done many times. It's especially if they've had trouble, keep them in place.
We're running a little thin on time. Tons of questions coming in. You guys got emails from me this morning. We're not going to hit all these questions, but feel free to respond to the email from me this morning, and we can get some of these other questions answered.
Yeah, absolutely. Again, this just I only got a couple more here, Paul, and we'll go to that. But this just shows the rainwater collection here towards the central and end of the lagoon, and then we certainly recommend using pumps that aren't mounted on the cover, that are mounted on the bank, that make for easy collection. Keep your labor, keep your people off the cover. Certainly in the industrial world, this is almost a requirement from the safety standpoint. Usually a little more lax in the field in agricultural settings. We think it's a really good design, and it also keeps kind of electricity off the middle of the cover. Couple other things that we do, sludge removal is a big issue. Most covers that we install today are designed and have a piping system that's attached to the floor of the lagoon, and can be accessed, and sludge can be pumped out. But a lot of times we're looking at lagoons that, if you're looking for that 20, 25 year life of the cover, you can't remove the cover and get in there and work on it and then put it back in place, so to speak. That's not viable. So one thing that we've employed a lot are these hatches that we fabricate here in our shop. We install those. We can do those either at the initial install of cover, or we can retrofit those some point down the line. What we like about these is they allow for you can sample and figure out if you have sludge accumulation in an area where maybe your sludge removal system's not getting it out. You can put these in, drop a pump down directly in the area where you have the accumulation, and pump it out. One of our largest corporate customers, this is their preferred method for sludge removal now, and they're using that. We're retroing that on many of their covers, and it's really helped extend the life of the cover without having to remove it and replace the entire system. Another area, that all different designs, but mixing is a big issue that comes up. We've designed all kind of mixing systems, internal, external. What we're showing here is one that we use that's mounted through the cover. These become popular in the last 4 or 5 years. They can be put in, again, just like the hatches during the initial construction, or they can be retrofitted down the line. We're flying this one in by a crane to install it. This looks like an agricultural setting as well. And this is what it looks like when it's a finished product installed, suspended from the cover. So that's just another kind of feature that's kind of been a new development, recent development in the last 4 or 5 years, is a way to handle the mixing requirements. Paul, how am I doing on time?
So we're at time. What I'll say to folks is the bulk of the presentation is done. We can stay on and answer questions as long as you'd like. The next formal talk is Plan ET Biogas at the top of the hour, but you're welcome to split. Thanks for coming. But if you'd like to run more questions by Bland, we've got a few here, and you're welcome to stay on and be with us. So do you want to just wrap up your speech, Bland, and we can get questions?
The main thing I would encourage, Paul, is that anybody that's involved in a project that has a lagoon coverage, just engage us early. We do a lot of budget early stage work for folks, you know, at no charge, you know,
Yeah.
to kind of help in the initial design and planning of projects. And we usually that really helps yield a much superior product down the line. So, you know, we appreciate the opportunity to be with you here today. As a part of the Biogas TV and your symposium, Paul, and I'm happy to answer any questions.
You're welcome. You're welcome. So these are all HDPE, or do you use any other cover materials?
HDPE standard is 60 mil liner and usually 80 or 100 mil on the cover.
So speak to, you know, annual maintenance. If somebody said, okay, Bland, you know, every April I'm going to do X. What should you do every year to a lagoon?
Yeah. Well, first of all, on annual maintenance, it's difficult for a owner to perform maintenance because usually it's going to involve probably some welding, and so if you don't use PFF, I certainly would get somebody that's very experienced in thermoplastic welding as well as covers. But our maintenance program would consist of an annual inspection where we would walk the entire cover, usually taking the as-built, noting any areas of stress, anything that's broken, patches of straps, ballast pipes that are stressed or out of position. And then usually we can handle all those type of repairs and we'll be prepared for that, minor repairs while we're there. If it's a bigger or larger repair that would sometimes requires removing all gas from underneath the cover for significant welding and things of that nature, we would kind of plan that and go over that with you. But usually it's an annual inspection with our maintenance crew, go out and provide it, and of course full reporting back to the owner of what we found, what we do. The other thing I would like to add too is sometimes that we do have a full maintenance crew that's all we do is we're out, you know, that kind of short order cooks. We can usually be there, respond pretty rapidly. But in addition, we have emergency repair kits that we can send if there is a gas leak or other things with tape and patches that can kind of usually get an owner through until we can get there.
So another question here, when you use a hatch for sludge removal, what is the process? Do you need to draw down the lagoon?
No, you don't. The operating level stays consistent. I'm not sure if you could tell in the, I'll see if I can flip back to it real quick. On the hatch right here, that is an 8x8 or a 10x10 of HDP plate stock, sheet stock that's there. So it provides a lot of stability. You roll usually an air-tired gantry out there, roll easily along the cover, and then you would lower a pump down from that gantry into the lagoon, but you certainly don't adjust the water level.
Okay. Thank you, Bland, for your experience. Everyone, always feel free to reach out to Bland for some help at Plastic Fusion Fabricators in Huntsville, Alabama. So with that, I need to keep the line open for the next talk at the top of the hour, but for Covered Lagoons, we're wrapped.
Great. Thanks, Paul. Appreciate it. Thanks to your audience.